Hello and thanks for watching. In chapter 4 I've taught you 5 tools for calculating angles. In this video I will explain how you can use the 6th and 7th tool in your toolbox. In this paragraph we'll be calculating angles again, so make sure you always write down all intermediate steps. Are you ready? Then let's start paragraph 7.3. By now, our toolbox consists of 5 tools. Right angles are 90 degrees, straight angles are 180 degrees, full angles are 360 degrees, opposite angles are the same, and a bisector is half of an angle. As I said in the intro, today I will teach you the 6th and 7th item on our list. And both of them have everything to do with triangles. You see, it doesn't matter if we were to look at this triangle, or this, or even this one. All triangles have one thing in common. The sum of the angles is always equal to 180 degrees. There is no exception to this rule. So, if you happen to know 2 of the angles, you can always calculate the third one. Easy. In this triangle, angle A should be 50 degrees. As angles B and C add up to 130, leaving me with only 50 degrees. This rule is called the triangle sum rule. When using it in an exercise, write it just like the other tools' names behind your line. So, when you need to calculate the size of angle D, check the other angles. Angle E is 32 degrees and angle F is 90 degrees. Remember, this symbol means the angle is a right angle and thus 90 degrees. That means that angle D is equal to 180 minus 90 minus 32, which is 58 degrees. And that is toolkit number 6. On to the next. Number 7 is the use of base angles. Base angles are the equal angles in an isosceles triangle. By using this in combination with rule number 6, we can calculate the angles in even more triangles. An example. In this triangle, we see these symbols on the side, meaning they are the same size and thus we're speaking of an isosceles triangle. That means that angle B and angle C are the base angles and are the same size. And that means angle B is also 40 degrees. And because the sum of the angles should always be 180 degrees, the remaining 100 degrees are in angle A. Now I hear some of you saying, but sir, angle A is an acute angle, so it should be less than 90 degrees, right? Then I would say, you are absolutely right, but this is only a sketch. Making a sketch is a good way for calculating angles, but you can never believe everything in sketch. Only trust the symbols you see and the numbers present. And with base angles in our pocket, our toolkit consists of 7 tools. In the last paragraph, I will add the last 2, alternate and corresponding angles. Now that we have a bigger list, let's practice. This here is triangle ABC with angle A equal to 40 degrees, angle B equal to 80 degrees, and CD being the bisector of angle C. With the use of our toolbox, we can calculate angles C1 and D2. Sometimes it can be tricky to figure out where to start. My advice, start by finding triangles and use the triangle sum, because triangles are the easiest to find. If we were to look at triangle ABC, we notice that we already know 2 angles, A and B. This allows us to calculate the size of C12. 180 minus 40 minus 80 is equal to 60 degrees. And because CD is the bisector of angle C, we know that angle C1 and C2 are both 30 degrees. Now let's calculate the size of angle D2. Again, we look for a triangle. In this case, triangle BCD. We know that angle B is 80 degrees and angle C is 30 degrees. This means that angle D2 is equal to 180 minus 80 minus 30, which is 70 degrees. And that's how you use the triangle sum to figure out your angles. Let's do one more, a big one. Take a look at this figure. Let's calculate angles S1 and R2. Pause the video if you want to give it a try, and when you're ready, keep watching to see how I approach this problem. To start, let's take a look at our toolbox. As I said earlier, looking for triangles is most of the time the best way to start. But we only know angles P and T. Going from there, we could calculate the size of angle Q2. 180 minus 40 minus 90 is 50 degrees. Although it doesn't help us directly with finding S1 and R2, we might find a use for it later. We also see these symbols in our picture. These symbols mean that these lines are the same size, and thus triangle PRS and triangle QRS are both isosceles triangles, meaning they have base angles. In triangle PRS, angles P and R are the base angles, meaning angle R is also 40 degrees. And this allows us to calculate angle S1 with the triangle sum. 180 minus 40 minus 40 is 100 degrees. Halfway there. With angle S1 being 100 degrees and angle S12 forming a straight angle, angle S2 must be 180 minus 100 is 80 degrees. And moments ago, we concluded that triangle QRS is an isosceles triangle and has two base angles which are the same. In QRS, those angles are S2 and Q12, meaning Q12 is 80 degrees. And that means that angle R2 is 180 minus 80 minus 80 is 20 degrees. And with that, we have achieved our goal for this exercise. In the next video, I will teach you the 4 special quadrilaterals you need to know. Make sure you bring your compasses and your pencil because you will need those. I hope to see you next time. Thanks for watching and good luck on paragraph 7.3. Bye bye!